On this third item, we're asked to find the pullout force at the nails at C. We have a pry-bar, and the nail is at C. We're going to assume that that pullout force is vertical. So as far as the pry-bar is concerned, the nail is going to be pulling back here. The point at B then would be like a pin type surface, assuming that we've got friction, and we're going to need this for some level of equilibrium here. There's your Bx, your By that would go along with the situation. Our P value, we're told, is 95 pounds, and that our angle of inclination is 27 degrees. Right, so all we really need to do to find this pullout force is to some moments about point B. It's going to involve trying to find maybe a perpendicular distance. That looks complicated to me, so immediately I think what I want to do is replace the force with two orthogonal components, because I think that will be just simply easier to work with. So that's really our step one, is find Px and Py. So Px, of course, is just P times the cosine of 27 degrees, so 95 times cosine of 27, that would be 84.64 pounds, and then P sub y would equal P times sine of 27 degrees, and that would be 43.13 pounds. All right, so now we've got those. Again, what we're going to do is we're going to find the sum of moments of these forces, so we need to go figure out some moment arms, and so we need this distance from here to there. That's going to be 18 is on the hypotenuse. We got 70 down here. We went opposite of that, so 18 times sine of 70 degrees, and that's equal to 16.91. What would that be? Inches. And then for the other one, we're going to want to know this total height here. That's going to be 18 cosine of 70 degrees. Why does that feel bad? That's because I'm writing this exactly opposite. That's why. So if you're confused, you should have been. That should have been cosine, and that should have been sine. Oddly enough, when I worked this out beforehand, I did the exact same goofy thing here. Opposite over there, I wanted the adjacent over here, and so 18 times 70 cosine should be a small number, not a big number. Goofball. So 6.16 inches. So now that should be correct, ready to go for our then final step here, equilibrium. We can sum moments about B. Let's take counterclockwise as positive. We'll have 4 inches times C, and then plus, we got P sub y here, that's 43.13 pounds, times its moment arm, 6.16, and then minus our 84.64 times its big moment arm, 16.91, set it equal to 0, solve for C, and let's see what we get here, 84.64 times 16.91, that would be pound inches, minus 43.13 times 6.16 equals 1165 and change, divided by 4 equals 291 pounds. Ooh, I like that. Put in 95 pounds, get out 90 or 291. That's kind of a good deal. That's why pry bars work the way they do. And so now the only tricky thing is how didactic do you want to be? The reaction at C is actually acting downwards. If you say what's the pull-out force on the nail, then your real answer, if you want to be really kind of, you know, nasty about it, is 291 pounds acting up because it's a pull-out force, not a push-in force.